This week for the wiring diagrams assignment, we're going to do another boiler diagram. It's going to be a little bit different this time though. This right here is the RayPak Raytherm water heater. Click on that. You'll see several different documents here. I want to start with the wiring diagram, but take a look here. You're interested in what is a RayPak Raytherm water heater. That's what it looks like. Boiler looks like that. A relatively small, light commercial type boiler. I'll go back and we'll look at the RayPak wiring diagram. And this is a fairly simple diagram for a RayPak boiler. Make this a little bit smaller. One of the problems with this diagram is that it kind of looks like a ladder diagram, but it's not. Very difficult to troubleshoot from this, because when you follow logic from top to bottom, left to right, it's not there. So what I've done, I've used this in my class for several years now, so if you're in the MES 2 class, you'll get to see this again next year, I'm sure. We're going to redraw this diagram, which really is more of a picture, I would say, than a diagram. And we're going to figure out what this is right here, a solid state economaster device. What is a solid state economaster device? Well, when you start looking at this, you're starting to try and figure out, okay, the power comes in here, there's a power switch, comes down, goes to TP7, goes to the transformer, neutral comes back, goes to there. Now nothing here really looks like it's making any logical sense. So what we're going to do is we're going to redraw this drawing to a ladder type diagram that makes better sense. So this is where we're going to convert that pictorial drawing to a ladder diagram that we can actually use to troubleshoot, and primarily we want to figure out what a solid state economaster device is. So for this assignment, you are going to make a drawing of what you see me doing on this next 4 screens, and then you are going to submit that, and that's going to be 50% of your grade. There will be some questions, but that will only be the other 50% of the grade. So you have to do a hand drawing. Now, if you look down here, you'll see this is a hand drawing that I made from years ago when I was trying to redraw this, and this is what I had been using in class, but I wanted to do something a little bit neater, a little bit simpler to understand, or maybe clearer to understand. So we're going to start with this, and what you're going to do is you're going to get a piece of paper, and you're going to start with this. You're going to put a 120 VAC. You're going to have the wire from the 120 volt coming over to H here and there. That's hot and neutral. And then you're going to have on your ladder diagram, you're going to have 2 rails that come down. So that's going to be the beginning of the drawing. This will be the next step in the drawing. When you look at this drawing here, what we're going to do is we're going to follow this 120 volt hot. There's the power switch. Here it comes over to P1. Internally, they show a jumper from P1 to hot. Here's P2. Here's the transformer. Here's the pump. Here's TP6 and 7 on the solid state economaster device. So we're going to redraw this in a ladder type diagram that hopefully will make more sense. And that's what you're going to start right here. We've got power coming down, goes to the power switch. This is what you're going to draw. Power comes across, goes to terminal H on the low water cutoff with a jumper down to P1. Here's another jumper that goes up to TP7. So after the power switch, power goes to HP1 and TP7. Of course, since it's a electronic low water cutoff, it has to have power. There's hot. Here's the neutral. Here's the circuit that closes when the probe does detect the boiler is full of water, and that powers the transformer. And up here, our SSE, or solid state economaster device, energizes the circulating pump for the boiler. So I've kind of already given it away, but why would they call the pump controller an SSE, or solid state economaster device? Maybe we'll figure that out here in just a second. So here's the next part of the drawing, because if you look at the diagram here, you'll see that the 120 volt is just this right in here. Now everything after that comes off the transformer. All of this down here is 24 volts. So that's what we're looking at here. We've got power coming down from the transformer, 24 volt AC. Got a blue wire and a white wire, and this is not the 120 volt hot and neutral rails anymore. Now the rails here and here are 24 volt. So 24 volt power comes down, goes to a plug terminal number 1. It's actually a Molex plug, but it also feeds on the solid state economaster. It feeds TP1. On the neutral side for the solid state economaster, it feeds TP2, and then there's also a TP5 that you'll see on the other diagram that has a jumper. And here's our series circuit of safety controls. And this is one of the things with this RayPak drawing that you have to understand that is not typical for a lot of different a lot of other manufacturers, but kind of strange for, I think, for a manufacturer to do this. But you'll see here's 2 high limit controls. Here's a pressure control. Well, if it's a steam boiler, you'll have a pressure control, but if it's a hot water boiler, you'll have limit controls or temperature controls, and that's what these 2 symbols show, a bimetal type or some type of a temperature sensing high limit. Here's a dual stat. Some controllers, the high limit and the operating control, are both in the same enclosure. So this series circuit here that goes between Molex plug terminal 1 and terminal 2, you know, you're not going to have all of these, and here's what I think is kind of crazy, and you'll see this on the RayPak drawing here. You see above the low water cutoff there's a box, and then above all of these series of safety controls there's a little box. Well, they expect that when you pull out this diagram, which is a universal diagram for many different boilers that RayPak makes, you will go and you will put a check mark on this box or that box or this box or that box or that box to indicate that that is actually installed. Anything that doesn't have a check mark in the box is not installed. Crazy. I don't think that's a good way of making a wiring diagram, but that's the way they do it. So on my diagram here, on the diagram that you're going to draw, we're going to show all of them just like the typical drawing, but understand that not every boiler is going to have 2 high limits of pressure switch and a dual stat. None of them are going to have all that. They're going to have 1 or 2 of these, but not all of those. So once you get that series circuit drawn, and I want you to do a nice, neat job. I want these to really look like the symbol for temperature control, a pressure control. They're all shown as normally closed, break on rise, and that's what a high limit will do. It's normally closed. If the bimetal expands, it'll push up and it'll break. The pressure switch is shown to break on a rise in pressure, and the dual stat. So make sure you draw them correctly. That will all figure into the 50-point grade that you get for doing this drawing. And then when it gets over here to terminal 2, that's when it goes to TP4 of the solid state economaster. And now I can tell you that the function of the solid state economaster is to start the pump. That is the circulating pump for the boiler. and it starts the pump immediately as soon as all of this circuit is closed and we have a call for the boiler to start. It energizes terminal TP4, turns on the pump. But is that all it does? We'll look a little bit further here and you'll see there's more to it than that. And then here's the final part of the drawing. After we get power to terminal 2 or the Molex plug here and TP4 of the solid state economaster there, then we go to a terminal TH, and that goes to the flow switch. Well, right here, after it came off here, the TP4, that's when we told the pump to start. So now we have water flow, and the flow switch should make. Flow switch is shown as a flow switch, the little triangle down here, and it's shown as normally open because it is not closed until there is actually flow. So it's showed as normally open, closes with flow. Once we get flow, we get 24 volts over here on the Honeywell S8610. And actually, I should have probably made that an S8600, but I'll show you a couple of the Honeywell manuals, and you'll see the 8610 is actually a universal replacement. But terminal 6 is how you power the ignition control, and like you saw back a couple weeks ago, not every boiler is going to have a flame safeguard. Some of them will have ignition controls depending on the BTU rating, and this one actually has an ignition control. So the 24 volt power on terminal 6, here's the common of the 24 volt on terminal number 5 because it is an electronic type controller. As soon as you put power on 6 and it's got neutral on 5, it goes through its sequence. Well, the sequence would be start the spark, open the pilot valve, and sense that the burner or the pilot has lit, and it does that with the same same rod that does the spark actually does the sensing. As soon as it senses the pilot is lit, it energizes this terminal here, and that does 2 parallel gas valves. So it energizes 2 gas valves at the same time. Got a little bit of time left. So in the sequence here, when you turn the power switch on, as long as there's water in the boiler, this will make, you'll get 120 volt here, you'll get 24 volts coming down here. Solid state economaster device is powered. Your safety circuit here, if everything is closed, it turns the pump on. Flow switch makes, ignition control takes over, lights the pilot, senses, make sure the pilot's lit, energizes the main gas valve. Once everything shuts off, or excuse me, once the temperature comes up and one of these controls opens, then we lose power on TP4, we lose power on terminal 6, which shuts off the gas valve and shuts off the burner. But you'll see that the solid state economaster, and I've got a little information about that in one of the manuals we're going to look at here. It is a delay, and it's set for, I think the factory setting is 7 minutes, that after the boiler, after the burner shuts off, after we lose power right here on terminal number 2, this contact here stays closed for an extra 7 minutes to make sure that we extract all the heat out of the boiler. Just like your furnace at home, when the gas valve shuts off, the blower doesn't shut off right away. There's a little bit of time for the blower to run on, a little delay to make sure that you extract all the heat out of the heat exchanger.